So in the last class we were talking about perceptron. Okay, we spoke about perceptron and we saw about the perceptron and MP neuron. So x1, x2 till xn. Okay, the difference between perceptron and MP neuron was the difference in the weights. Okay, there the weight was not given. Here the weight is given, and we saw all these equations. Okay, and we multiplied our input with the weight, and if it is greater than threshold and less than threshold, then we also saw about all these things. Okay, then we compared MP neuron and perceptron. Okay, and then we saw about single layer perceptron, what was happening there. So xi into wi plus the bias, all those things we saw. Okay, if it is greater than theta, if it is less than theta, then we saw about perceptron algorithm. Okay, is used for supervised learning for binary classifiers. Okay, for classification we go for single layer perceptron, supervised layer, all these things we saw. Okay, and we were speaking about this. Okay, so what is happening here? We also spoke. So given x1 weight, x2 into w2, xm into wm, it is given, we are aggregating it. After aggregating it, the output is given to the activation function. Okay, the output is given to the activation function. The activation function will give us either 1 or 0. Okay, if it is greater than or equal to some threshold, whatever you call it as, it will fire 1. If it is less than the threshold, okay, it will fire 0. Okay, so and then what we are going to do, we are checking the output. Okay, whatever it gives, we are checking the output with the target value, because a classifier means what? Already the labels are known to you, right? Already the labels are known to you. So what happens there is, when our label matches up with the classified one, where the predicted value matches with the target value, then okay, fine, we will go ahead to the next input. But in case if it is not matches, we are going to update the weights. That is the error, right? That's the error. Okay, so say for example, if our target is also 1 and if the output is also 1, then the error is, sorry, for example, if the target is also 1, the output is also 1, then the error is 0, then we will not update the weights. It means that whatever the weights we have taken is correct. But if the target is 1, but if the output is 0, then there is an error. Or if the target is 0 or the output is 1, again then there is an error. Getting the point? Or if the target is 0 and the output is also 0, then there is no error. Getting the point, students? What I'm trying to tell you here is, yes, we have the classified label already. Okay, our activation function will produce 1 or 0. With the help of a problem, I will tell you in a more detailed way. You will be able to understand. But before going to that, okay, I'm just explaining you the entire process, how it works. Okay, consider if our target is 1 and the output is 1, then what is the error? 0. Then no weight updation. There is no error, right? Because 1 minus 1 is 0, there is no error. Pakka. Our system is working pakka. Okay, but our target is 0 and our output is also 0. Again, there is no error. Matching. When will the problem arise? When will you update the weight? When there is a mismatch. When the target is 1, but the output is 0, error. Or when the target is 0, the output is 1, error. Getting the point, students? Hello, getting the points? Hello?
Yes, sir. Yes, sir.
Okay, then you will go ahead when there is an error. In these two cases, just to make you understand, see the two cases, then there is an error. Then you will go ahead and update the weights. So that's such that, okay, our target and the output matches. Okay, fine. So why we are doing all these things, students? We are going to linearly separatable. Okay, classify means what? Okay, can you see? There are some situation in AND we were able to, for OR we were able to linearly separate, right? Anything above 1 and everything above 0. Okay, for and also we were able to separate anything above 1 and above tautology we were able to separate. Okay, for 3 input we were able to separate. Okay, those were the examples for linearly separable what we saw. So this is an example of linearly separable. Can you separate this? Can you separate this? Wherever you put the line, can you see? Wherever I cannot separate, non-linearly separable. Okay, I cannot separate. I cannot classify because both the sides. This is an example of linearly separable and non-linearly separable. Can you see? For AND gate, we were able to separate. For OR gate, we were able to separate. Can you see anything all above are ones and all below this is zeros? Okay, all above this is ones and all below this is zeros. But non-linear XOR. If I draw something like this, okay, let me just redraw this. Something like this. If I draw. Okay, then see, I'm not able to separate it all. So XOR is the best example of non-linearly separable. You cannot do XOR, non-linearly separable. Okay. So now students, the perceptron training rule, as I told you, okay, I will explain you the algorithm while explaining you the problem. Okay, so then you'll be able to understand. Okay, so first we initialize the weights. Okay, then we compute the training samples. Okay, then we compute the output value. Then we update the weights if the target and the output does not match. Okay, then we'll see. Okay, the formula is okay to update the weight. Also, I will teach you with the help of the problem. Okay, so we have the more formally written as weight updation equal to Wj plus delta Wj. Okay, this delta Wj is calculated using alpha is the training rate. N or alpha. Okay, this both are same. Okay, kindly remember both are same. Okay, this is the actual output which is there in the classifier. What our classifier is there is doing, which is already there in the data set. This is the predicted output. This is the predicted output. Okay, this is the predicted output. Here we are calculating the error. This is the predicted output, and we are multiplying it with that particular variable input. Okay. So this is the formula. We'll come back to it. Okay, we have the same thing we are doing. Okay, when we are predicting, when our target does not matches with the actual. Okay, that is this is the actual, right? T is the target means what? Actual, which is already there in our data set. Actual, and who is the predicted output? Who is the predicted output? So if our actual does not matches with the predicted output, then we will use this formula for updation. Then we will see while work it out, you will be able to get it done. Okay, let us do a problem. Okay, let us do a problem. Now students, now kindly listen. Okay, now based on this one, all your slides you will be able to understand all the algorithm, formulas, everything. Okay. So now students, input is given here. Okay, can you see? Input is given 1 1 1 1 1 minus 1. Okay, 1 0 minus 1. Okay, 1 minus 1 minus 1. Okay, 1 minus 1 1 and 1 0 1. Okay, initially the weight is given as 1 0 0. That's all. The weight is given as 1 0 0. Based on that one, you will be updating the weights. You will be deciding what you have to do. Okay, then this is the data set which is classifying 1 or 0. This is the desired. 1 1 1 0 0 0. It is giving. Okay, this is the target output. Okay, it is already given. Okay, this is what for these set of inputs. This is the desired output. It is already given. Okay, it is already given. Then we will be calculating the weights, actual, okay, update, and we will be seeing the new weight. Okay, step number one. Okay, what is step number one? Step number one. Yes, one students. the Perceptron training rule works. Okay, can you see? Here bias is not given. Okay, so we'll keep the bias as 0. Okay, what is it? Summation of, okay, so you have been given with x1, x2, x3, okay, 3 inputs are given, weights is given, weights are given. So what is the step number 1? This is the formula. Okay, now let's consider the bias. Assumption is the bias is given as 0. Okay, the bias is given as 0. Okay, our assumption is. Okay, so now this is the step number 1. Okay, very simple, right? So what are we doing here? So for the input, what is the input? x1, x2, x3. Let us have this as x1, x2, x3. x1, x2, x3. Okay, 1, 1, 1. 1, 1, 1. This is, we can have it as W1, W2, W3. W1, W2, W3. Okay, so what are we supposed to do? x1 into W1 plus x2 into W2 plus x3 into W3. Okay, so x1 into W1. What is x1 into W1? 1 into 1, which is 1, plus 1 into 0, which is 0, plus, okay, 1 into 0, which is 0. Okay, students? Okay, so I am summing up. Okay, here we are keeping the bias as 0. So we are not taking the bias into consideration. Consider the bias as 0 for the given sum, for the given problem. So 1 plus 0 plus 0 is how much, students? 1 plus 0 plus 1 is what? Hello? Hello?
So 1.
1. Okay? 1. So what are we doing? What we have to do now? What do we have to do now? Go back. Go back. Go back. Okay? If it is greater than or equal to 1, okay, we are going to give it to the activation function, right? Okay, we have got, okay, whatever we have done, we have got 1 over here. 1 plus 0 plus 0. We have got it over here. 1 plus 0 plus 0, which is 1. So we are going to give it to the activation function. Okay, it is 1 greater than or equal to 0. 1 greater than or equal to 0. Okay, we can have 1 greater than 0. Okay, let's not take equal to. Is 1 greater than 0?
Yes.
Hello? Hello?
Yes.
Yes or no? Yes. So if it is yes, then what will be the output of the activation function? What will be the y? What will be the value of y? In this case. Here, please tell fast, Pa. Here, people are able to understand or not what I am teaching? People are able to understand or not? Hello? People are able to understand?
Yes, sir.
Yes, sir. Understand.
How many of you are able to understand? Raise your hands. Okay, fine, fair enough. Good. So if it is greater than 1, we can have it as something like this. Okay, if it is greater than 1, okay, that is consider the threshold value is 0 over here. So is 1 greater than 0? Is 1 greater than 0, students?
Yes.
Yes.
Yes. So it will fire 1. It will fire 1. So what it is firing? So since we have got 1 plus 0 equal to 1, 1 is greater than 0, so it will fire 1. It will fire 1. Okay, it will fire 1. Now this one, okay, after the activation fire function 1, we are going to predict with the target value. What is the target value? Which is the desired value. Target value is the desired value. Desired value, target value, okay, whatever may be the thing, you can call it. We are going to compare. Okay, so now what have we got? Okay, so what have we got? So what is the target value, students? 1. Okay, and what is the activation function output? What is the activation function output?
1.
1. If it is matching, what we will do? Will we update the weights or will not update the weights? We'll update the weights or will not update the weights?
Will not update the weights.
We will not update the weights. So the desired, okay, is also one. If this is confusing for you, this is the target and this is the predicted. We can have this as a predicted if this is confusing for you. Okay, so our predicted value is also 1. Can you see? Our predicted value is also 1. So the weight updation is not required, and the new weight is the old weight itself. The new weight is the old weight itself, which is 100. Is this clear? Is the first step clear? Is the first step clear?
Yes, sir.
Yes. Okay. Now we will go to the second phase. Okay. Now what is the second phase? Input is 1, 1, minus 1. What is the input? x1, x2, x3. 1, 1, and minus 1. Okay. What is our weight? W1, W2, W3. Okay. We have to take the latest weight. Okay. 1, 0, 0. 1, 0, 0. Okay, what is our Perceptron rule? Okay, that is x1 into w1. So which is 1. Plus x2 into w2. 1 into 0 is 0. Plus minus 1 into 0 is 0. So 1 plus 0 plus 0 is 1. 1 plus 0 plus 0 is 1. Okay, so this is 1. Can you see? We'll come back here. Okay. So is 1 greater than 0? Is 1 greater than 0? Hello? Yes. Is 1 greater than 0? Yes. So it will fire 1 or 0? 1. 1. So it is firing what? It is firing 1. It is firing 1. Okay? It is firing 1. So this one has to be compared with the target. This is the predicted value we have got. Okay? The predicted value we have got. So now go back to the table. So what have we got? 1. But what is the target value given in the table? 1. Are both are same?
Yes, sir.
Yes. Is the weight updation required?
No.
No, weight updation is not required. So the new weights are the same. Okay, now we'll go back to this. 1, 0, minus 1. 1, 0, minus. Just give me a second, please. Hello. 1, 0, minus 1. x1, x2, x3. 1, 0, minus 1. What is the weights? 1, 0, 0. W1, W2, W3. Okay? So 1, 0, 0. 1, 0, 0. So what are we going to do? The Perceptron rule. So 1 into 1 is 1, plus 0 into 0 is 0, and minus 1 into 0 is 0. So what we have got? What we have got? What is the summation? What is the aggregate? 1. Okay. So what is the rule? If 1 greater than 0, what it will fire? What it will fire?
1.
1. Okay. So we have got 1. So we have got 1. What is the target function? What is the target function?
1.
1. Is both are equal?
Yes, sir.
Yes. So no need to update the weights. The weights remains the same. Is it clear? Is it clear, everybody, till here? Everybody, is it clear?
Yes, sir.
Hello?
Sir, excuse me,
Yes.
sir. These
Yes.
target values would be provided to us.
Yes. It's here. In a supervised learning, what happens? What is a supervised learning? What happens in decision tree? Just to make you understand, what happens in decision tree? Sunny, hot, okay, then humidity, heat does not play. No. Yes or no?
Yes, sir. Yes.
Okay, warm, winter, sunny, plays. So the final class table is provided to you, right? In the form of yes or no? The target
Yes, sir.
table is provided to you, right? The same way. A target label, we know. That's the main aim of the supervised learning. Supervised learning means what? You know the output. Please kindly understand the whole concept of supervised learning. This is for everyone. Supervised learning means the output is already known to you. Then when a random input is given, okay, it should predict the correct output. And then you compare, okay, by the help of the that is the true positive to negative. In the class have I taught you this one confusion matrix? In the class have I taught you the confusion matrix? Hello? In the class have I taught you the confusion matrix? Not in the lab. In the lab I have taught, but in the class I have taught you. Hello?
No, sir.
Yes, sir.
Okay, kindly check it. I think so. Okay, but me in the one more time I will teach you. Okay, now don't mix lab with theory. Okay, so fine. Okay. So till here we have done. Now next part. So what is the input? 1 minus 1 minus 1. Okay. So x1, x2, x3. 1 minus 1 minus 1. What is the weight? W1 is 1. W2 is 0. W3 is 0. W3 is 0. Okay. Now what do we do? Perceptron rule. What is the perceptron rule? x1 into W1 plus x2 into W2 plus x3 into W3. Okay, plus the bias we are keeping it as 0. Okay, so 1 into 1, which is 1. Okay, plus minus 1 into 0 is 0, plus minus 1 into 0 is 0, which is 1. Okay, which is 1. 1 greater than 0. 1 greater than 0. 1 greater than 0.
Yes, sir.
1 greater than 0? Yes. Yes? Yes or no, students?
Yes, sir.
Yes, sir.
Yes. So what it will fire? What it will fire?
We
One.
find 1, sir.
1. It will fire 1. Very good. Excellent. Now, what it has fired? 1. What is the 1? 0. Is there a mismatch?
Yes.
Is there a mismatch? Yes. Not equal to, right? Yes or no? Not equal to. Yes? 0 not equal to 1. If it is yes, that is not equal to, then you update the weights. Now what is the formula to update the weights? That is, the formula to update the weights is, as I told you, Wj equal to Wj plus delta Wj I'll just write down in similar terms, simple terms. Okay, W1 new. I'm going to update the weights of W1 and W2. W1 new equal to W1 old plus alpha into T minus of target minus output into x1. This is a simple formula, students. Okay, this is a simple formula. Okay, so this one is the W1 old. So W1 new. Okay, we will calculate this as W1 new. So this is the W1 new. Okay, so W1 new equal to W1 old plus delta Wij. Delta Wij is the learning rate. Learning rate. This is theta. This is theta is alpha. Both are same. Okay, in few books you will find this one and this one. Both are same. Okay, into target minus output into xi. That's all, students. Now we will see. Okay, now what is W1 old? Okay, what is W1 old, students? This is W1 old, right? 1. W1 old is 1. Okay, alpha, let us consider alpha for the entire problem as 1. Alpha is given as 1. Learning rate. Okay, so it can fluctuate between 0.1 to 1. Okay, for this particular problem, we are setting the alpha as 1. Okay, we are setting the alpha as 1. Okay, so 1 into what is the target value, students? What is the target value? What is the target value? What is the target value? Given value?
0.
0. What is the output which we have got? What is the output
1.
we have got?
1.
1 into x1. What is x1?
1.
What is x1? 1 into 1. So when you do 1 plus 1 into minus 1 into 1, right? So 1 plus of minus 1 into 1 is, this is minus 1. So which will be what, students? 0. This will be 0. Is that clear? The new weight for W1 is 0. The same thing you will be calculating for W2. W2 new equal to, okay, just a second people. Hello. Yes, can you hear me?
Yes, sir.
So, what is the formula to update? W2 old, okay, plus alpha into T minus of output into x2. So, what is W2 old, students? What is W2 old? 0. Plus alpha given as 1. Target value is 0. What have we got? Minus 1 into x2. Into x2 is what? Minus 1 into minus 1. So 0 plus of 1 into minus 1 into minus 1. So what are we going to get? 1. Is it clear to everybody? Is it clear to everybody
Yes,
what is
sir.
happening? Hello?
Yes, sir.
Okay. So now W3. W3 new equal to W3 old. W3 old plus alpha into T minus of output into x3. Okay, so in general, how will you write, students? Wi new, the general formula, equal to Wi old, okay, plus alpha into target minus of output into xi. Okay, this is a general formula. Okay, so now what is W3 value, students? W3 value is 0. Plus alpha value is given as 1. And what is the target we have got? What is the target which you have got in the table? Just to make you understand. 0, right? 0. Minus of what is the output we have got? What is the output we have got? 1. Very good. Into x3. What is x3? What is x3? Minus 1. 3 is minus 1. So 0 plus 1 into minus 1 into minus 1, which is 1. Okay. So now we have updated W1, which is 0. W1, which is 0. W2, what is the W2? 1. And what is W3? 1. Okay, students, now let's go back to the table. So what did we do? So can you see? Can you see, students? So input was given as 1 minus 1 1. The weights were supplied as 1 0 0. There was a mismatch. So we need to update the weights. And what have we got the latest updated weight? What have we got the latest updated weight? 0, 1 and 1. Is this clear? Is this clear?
Yes, sir.
Sir, one doubt, sir.
Yes.
Sir, when we update the new weight, sir, how to make sure that the above values in table didn't change, sir? Like error didn't come in there, sir.
Exactly. Okay. Very good question. Excellent. It means that you have understood. Okay. So I will tell you in the next pass. Okay. So we have the next pass. That's why we go. So we will keep going till we will fix up one particular weight. Since you have asked this question, I will conclude it. Okay. And it's very good to think better than ahead. So we will conclude it in the final iteration. Okay. When we will get a final weight, which will be equal where the no weights of updations will be applied. Can you see? In the final thing, no weights of updations which is consistent with the entire training data. Is that clear?
So for all 6 data, we should iterate again and again till no error.
Exactly. That is what we are doing.
Yes, sir.
Okay? Okay, very good. In the 4th step itself, we have asked the final output before me telling. Very good. Okay, so the weight updation is required. And what is the new weight updation, students? So 0 1 1. 0 1 1. Is that clear? That is how that is called as Perceptron training rule. We are training the system using the concept of Perceptron. Okay? Is it clear till here? It's clear to everybody? Hello, till here everybody is clear?
Yes.
Now we are supplying 1 minus 1 1. Okay, what is the input? X1, X2, X3. So what is the input given? 1 minus 1 1 minus 1 1. And what is the updated weight? Can you see? The latest updated weight is 0 1 1, which you have calculated. For W1 0, W2 1 and W3 1. Okay, so what is the formula? X1 into W1 0 plus X2 into W2 plus X3 into W3. Okay, so minus 1 into 1 is how much? Minus 1 plus 1. Okay, this is 0. Okay, I'm just writing. Okay, I will not make you confused. 0. Okay. So 0 minus 1 is 0. Okay. Is 0 less than or equal to 0? Yes? Yes?
Yes, sir.
Yes, sir.
So what it will produce? What it will shoot?
1.
0.
0. It will shoot 0. So it has shooted 0. What is our target output? What is our target output?
0.
0. So is there any updation of the weight is required?
No.
Any change? No. So we'll pass it. Okay. Now we'll go to this particular input. 101. Okay. 101. Okay. 101. And what is the latest weight we have calculated? 011. So 011. This is x1, x2, x3. This is w1, w2, w3. So then we will be calculate 1 into 0 is 0 plus 0 into 1 is 0 plus 1 into 1 is 1. So 1. Is 1 greater than 0? Is 1 greater than 0?
Yes, sir.
So it will shoot what? 1 or 0?
1.
1. So it has shooted 1. What is the target output? What is the target output? 0. Is there any mismatch? Is there any mismatch? Yes, there is a mismatch. So mismatch means update the weights. We need to update the weights. Yes. So we need to update the weights. So W1 equal to, I'll just write it down quickly. New equal to W1 old plus alpha, that's the learning rate, equal to target minus of output into x1. Okay. So W2 new equal to W2 old plus alpha into t minus of output into x2. W3 new equal to W3 old plus alpha into t minus of target output, what we have got, into x3. Now substitute the values. So W1 equal to W1 old, what did we get? What is W1 old? 0. Okay, 0. Okay, I will just write it down here. 0 plus alpha is given as 1. What is the target output? What is the target output? 0. Target output is 0 minus of what we have actually received? 1 into x. So when we do the math, what happens? So we get minus 1, right? Yes or no, students? We get minus 1. Okay, the same thing. W2. W2 is 1. W2 is 1 plus alpha is given as 1. Target is 0. Okay, the actual output we have got is 1 into x2. What is x2? 0. So what are we going to get? 1. Because 0 into anything is 0 plus 1 is 1. Okay, so W3 is what? 1. Old. Plus alpha is given as 1. T is given as, target output is given as 0. What we have got is 1 into x3. This is x3. That's 1. Okay, 1 plus 1 to minus 1, which we are getting it as 0. So minus 1, 1 and 0 is W1, W2, W3. So what do we get? Minus 1, 1 and 0. Okay, minus 1, 1 and 0. This is the final output for after the first pass, first iteration. After the first iteration. After the first iteration. Is it clear till here, everybody? Is it clear till here, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay, very good. Okay, then we go for, okay, we will be converging it. We will be keep doing it again and again, okay, till we get, okay, that there are no errors. That is, there is no updation required. So let's see the second pass, what happens. Let's see the second pass, then we will go to the third pass and finally we'll end. Okay, so now So in the second pass, okay, we will start again. Okay, can I just run through it, or do you want me to again work it out? Since I have worked out everything, first pass, the concept is the same. You want me to run through it, or again work it out?
Run through it.
How do you want me to do, students? Hello?
Run through it.
Okay, so now the input is given. What is the target weight we have got? -1, 1 and 0. The target weight is supplied as 1. Okay, we know what is the output. So when we run through the summation formula equal to 1 to n wi xi, okay, and when we pass the summation value to the activation function, we are getting it as 0. So there is a mismatch. So we go for the weight updation formula. So we know that what is the weight updation formula. The weight updation is required, yes. So we get the new weights. Now the same thing we are passing it. Okay. So now the input is this. Can you see the weight updation is this? Okay, the desired is this. When we run through it, okay, then you can have it as this just to make you understand. So the predicted value, this is the target value, what is given in the data set. This is what is given in the data set. This is what we are calculating it through the WIXI and through the activation function. The predicted value. So again, there is a both are same. So the weight updation is not required. So the weight remains the same. Okay, now when we run through the third input, okay, there is a mismatch. So the weight updation is required. We apply the weight updation formula. Okay, so we apply the weight updation formula. So we get this, can you see? From 0 to 1, weights have been changed from 1 to 0. Now the same weights have been 1 to 0. Okay, you need to always carry over the new weights. So when we pass through it, okay, no updation is required, no weight updation is required. So when we run through it, no updation is required of the weights, no updation is required. So, but when we run through this, no updation, okay, then there is a mismatch. Then we run through the weight updation formula, and then we get these weights. Okay, then we run through the third pass. What is the latest weight? 0 to minus 1. Then we repeat the process. Can you see? Desired is also 1, actual is also 1. No weight updation. Then desired is also 1, actual is also 1, no weight updation. Then desired is also 1, actual is also 1, no weight updation. Desired is also 1, actual is also 1, no weight updation. Desired is also 1, actual is also 1, no weight updation. Desired is also 0, actual is also 0. So desired also 0, actual is also 0. Desired is also 0, predicted is also 0. So we no weight accuracy. So it means that this is the weight W1, which is 0, because we have started with the random weights here. Okay, because we have started with the random weights. Okay, initially, okay, we are starting with the random weights. We don't know what weight we are going to do for this one. And W3, okay, which is 0. These are the random weights. Alpha is also random. Bias is also random. Everything is random. We started with these things. Everything is random. Okay, and then we run through the perceptron algorithm. Then we converged at a point where the weights were, these are the weights for this given data set inputs, where our actual and the desired are working perfectly, where W1, W2 is 2 and W3 is -1. So these are the final weights where the no weight updation is required, where our prediction and actual, where the error is 0. So at the iteration 3, no weight change is required. So stop the execution of the algorithm. So the final weight is 0, 2 and -1. Now if I go back and explain you, can you see this one? This is in a different formula. Okay, alpha equal to target. Okay, T. Okay, yi is the T and y cap is the predicted. Or you can call it as the output into xj. Okay, this is the x1 formula. This is the Wi new equal to Wi old plus the delta Wj. Okay, now if you see, okay, 1 second students, 1 second please, one.
બેઠા બેઠા ઓછી કરું ફોટા ફોટા માતાજીના કેટલા પાદે ગયા ભગવાન છે હા તમારું બેઠા
Sorry for the interruption. Okay, so what did we get? Okay, so 0 into 2 into x1. So when we can get an equation of something like this, right? So 2x1 minus of x2 equal to 0. So now we can have 2x1 equal to x2. 2x1 equal to x2. Okay, 2x1 equal to x2. Now if I supply x1 equal to, say for example, 1. If I supply x1 equal to 1. Okay, so what will be the value of x2? 2. If I supply x2 as 2, okay, what will be the value of x2? 4. Okay, if I supply x3 as x1 as 3. X1 as 3. So can you see x2 value will be 6. So when x1, x2, x3 equal to 1, 2, 3, x2 value is so x2 value is what? What is the value of x2? So 2, then 4, then 6. But if I supply x1 as 0, if I supply x1 as 0, x2 will be 0. Okay, if I supply x1 as -1, x1 as -1, then what will be the value of x2?
-2.
-2.
Now can I plot like this? Can I plot like this? This is x1, right? And this is x2, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is -1, right? -1, -2, -3, -4, something, and it goes on. Okay, so now what did we get? Students? Now what did we get? See, when x1 is 0, x2 is 0. Okay, fine. Okay, when x1 is 1, x2 is 2. x1 is 1, x2 is 2. When x2 is 2, x2 is 4. x2 is 2, x2 is 4. Okay, something like this. Then x2 is 3 and x2 is 6. Okay, right? So you see, something like this. Okay, then what happens? So I just, okay, sorry for the thing. So it will something like this. This is 1 over here. Okay, consider this 1 over here. I have drawn it wrong. So then 0 comma 0. Then it will have -1 comma 1, -2, -3, -1. Can you see, students? I'm able to plot this line. Okay, then -1 means -2. So when x1 is -1, okay, I'm getting -2. Then -4. This one I'm getting. So what am I doing? Can you see this line? This is the line I'm getting. This is the line I'm getting. This is the decision boundary where I am able to classify my positive and the negative. Okay, on this side I'm able to classify it as negative, and on the other side I'm able to classify it as positive, linearly separatable line. Is that clear, students? Hello? For or function. Okay, is it clear? Hello?
Yes, sir.
Yes.
Yes,
I am able to classify, okay, given a particular input data set, okay, like how we did for perceptron, for and or kindly recall. So now for a given set of inputs, x1, x2, x3, I am able to write the thing and I am able to draw the conclusion, okay, and then I am able to draw a decision boundary, and I am showing you I am able to classify it. Okay, the same thing. Okay, only those models are
Sir.
linearly separable for and or. Okay, but not for nor. Okay, this is all about single layer perceptron, students. That's all. Single layer perceptron. Is it clear till now? Hello.
Yes, sir, clear.
Okay, so you people can leave, students. Thank you, because I think so. It's time for I took your extra 5 minutes of time. I'm very sorry about it. Thank you.